Hello and welcome to June 6th, coming at you live from 3004. Schmidt's here, along with
featuring Mr. Tawnis.
some students. I was counting and then I got distracted, but there's not a lot of people here, so we're recording this for you. Say hi.
Hi, slackers.
All right, we're learning about sequences. Door's locked. Sorry. Okay, there's two kinds. Arithmetic. I know it looks like arithmetic, but we're going to say arithmetic and geometric. Arithmetic is when it goes up by, when you can add to get the next term or subtract. So let's do an example. Let's do like 2, 4, 6, 8. What? Yeah. And for our geometric, let's do 5, 10, 20, 40, ... Okay, so arithmetic is when it goes up by a constant amount. So let's say when it increases or decreases by a constant, no, let's say a common difference, which we call D. So like Branson already said, in this example, 2, 4, 6, 8, our common difference would be 2. Because it's going up by 2 each time. And to figure out the common difference, you just take any term you want, say 6, and subtract the term in front of it. So 6 minus 4, 2. 8 minus 6, 2. 4 minus 2, 2. And I'm going to write that down, but first I just got to teach you a little teensy bit of term notation. We're going to call all the terms in the sequence a capital T with a little subscript. So that would be like term 1, so T little 1. This guy is like term 2, T little 2. This guy is term 3, so T subscript 3. This would be like T subscript 4. So T for term, and then the little letter is indicating which term it is. So for common difference, to calculate it, we could say, take term 1 and take term 2 and subtract term 1. That's like the equation for the common difference. And just like you saw in the Kahoot, term 1 also has a special notation, and it's an A. We don't put A1, we just say A. So that's the first term in the sequence. You can call it T subscript 1, or you can also call it A. Okay, so that's our notation. One more notation. We like to describe the general, like any term of the sequence. So we use a subscript N, and N just means like the nth term. So this is like the nth term. So like any term. And N is just the term number. So like you would replace the N with a number. Like, oh, what's term 2? So N is a 2. So that's just saying the second term. Okay. But if we say Tn, then that's just like the general any term. And we can actually make a formula to figure out any term. I could figure out the 100th term in the sequence like super fast by using this formula. T subscript N, like so just the general term, is equal to A plus bracket N minus 1 times D. So that's the formula for just finding any term in an arithmetic sequence. Let's practice. So using our sequence, 2, 4, 6, 8.
Yes.
Yes.
Yeah, so like 8 is just like the first term, or you just like 8?
Yeah. I'm just gonna rewrite my sequence. So let's let's fill in all these things. So yeah, like Fatima said, what's A? 2, just our first term. Yes, so this guy is our A. N is like the term number, and we don't even know what term we're finding, so we're just gonna leave N as it is. And what did we say D was? It's also 2. That's unfortunate. Not a great example. Anyways, D is 2 because it's going up by 2 each time. So it's our common difference. So all we're doing right now is we're making a formula that could represent any term in the sequence. So that's why we left N as N, because we don't know what we want. And then that's it, you're done, but let's just like expand these brackets and collect like terms just to make our formula look better. So Tn equals 2 plus, I'm just gonna multiply everything in the bracket by 2. So I'd get 2n minus 2. And then I'm just gonna collect my like terms. So what would I end up with after I collect my like terms?
2n.
Yeah, just 2n. I guess the 2 minus 2 went away. So this formula right here will get me any term in the sequence. So let's just test it out, make sure it works. What if I wanted to find, let's find the one that we know just to make sure it works. Let's find the 4th term. So we're gonna find T4, term 4. So all we have to do is replace the n with a 4. So 2 times 4 equals 8. Ha! It works. It's not like groundbreaking, guys. It's actually a linear relation where 2 is your slope and this other number that we don't have is your like initial value. That's actually what this is. So it's an arithmetic sequence, but also it's just a linear relation. Y equals mx plus b, it's kind of the same thing. Okay, what if we wanted to find term 20? What would we do? Yeah. 2 times 20. So term 20 is 40? Cool. That's it.
That's easy.
Yeah, it's pretty easy. I told you. Told you it'd be easy.
Yeah, French thought was gonna be hard though.
He did?
Yeah, that's so hard.
What? Okay, wait, I got a good one. What if I gave you a term? What if I said like the nth term is 82, and you have to tell me like what term number is that?
Divide it by 2?
Do you? Yeah, probably. So let's just use our formula. I know this is really easy formula, but anyways, Tn equals 2n. So we know Tn is 82, and we're just trying to solve for n. So we're going to do just what Nicole said and divide by 2.
Yeah, probably.
So n equals 41. Cool. So term 41 would be 82. All right, cool. That's pretty much it. Okay, that's an arithmetic sequence. Okay, I'm going to give you guys one, and you have to tell me you have to make the formula. Okay. Here is your sequence. It's 3. No, just kidding. Let's make this something harder. Okay, it's 17. No one likes the 17.
30.
Including me. Just kidding. 13. 9. 5. Just had to check. Okay, that's your sequence. See if you guys can find the nth. See if you guys can make a general formula. So fill in all this stuff. Yeah. Oh, did you already get it?
No, why the negative one? Oh, I need to figure that out.
Oh, why is it n minus 1? Oh, I think because it's... I think because like that's your first term.
Yeah.
And then when you're doing your common difference... Okay, wait, let me think this through. Let me think it through as we make it.
You got this mess.
It's because like that's term 1, so you would have to have 0.
Term 0. Yeah, to get term 0.
Yeah.
Yeah.
Because if you did the first one plus, then if you did n equals 1, then it would be plus d. Then you can't. Then that's not the first one anymore. That's the second one now.
That's the second one. Yeah. Yeah. Yeah.
I see this is the thing.
Did you guys get it?
Yeah, I think we got it.
Okay, what'd you get?
Oh, do we?
Yeah, n equals 17. Plus n minus 1. N minus 1.
Did you guys like expand?
I didn't do that at all.
What? Always expand it.
I'll have room on paper to do that.
What?
I didn't have enough room on paper to do that.
Okay. Okay, cool. So our formula is Tn equals 21 minus 4n. So it's going down by 4 each time, and our term 0 is 21, I guess. Yeah, so Elijah's right, in case you didn't hear what he said, Branson. He was saying like the n minus 1, it just accounts for your like term 0. So you're starting at 0 and then working your way up. So like, see how 21, like if you went back 4, or I guess added 4, you'd be at 21. So that's like your term 0. So then when you actually put in like n equals 1, you're actually getting the first term instead of like the second term. Does that make sense? No? Did I explain that bad? If you didn't put in the n minus 1, like if you had a plus n times d, then you'd end up with like 17 plus, or I guess 17 minus 4d. So then when you find minus 4n. So then when you put in like n equals 1, 17 minus 4 would be 13. You'd actually get the second term and then the third term. So like you have to put in the n minus 1 because you're putting in the first term here, and you need to, you're just accounting for that.
Did you say it again?
Yeah. So like if you didn't put in the n minus 1, if you just had like a plus n times d, then you'd have 17 minus 4n. So like if you were to put in, I want to find the second term. So you put in a so you put in a 2. So you'd get like negative 4 times 2 is negative 12. So 17 minus 12 would be 5. But you were trying to get the second term. Did I just do something wrong? Oh, 8. I just said 12. Okay, I'm having a day. Okay, say I put in 2 for n. I need to write this down. 17 minus 8. And then I would get 13. No, just kidding. I would get 9. Oh my God. But I actually wanted the second term. And the second term is 13. So I'm like a term ahead. So like I need to put in this n minus 1 just to account for the fact that term A here is the first term. Like I really need the second. I really need term 0. What an arithmetic sequence is, it's really like a linear relation. So you're really just, it's really y equals mx plus b. So you know your slope is negative 4 and your y-intercept is 21. So your y-intercept is like term 0. Like when x equals 0, what's y equal? That's like your y-intercept. So, but we don't have term 0. So you could actually not even use this formula. If you know how to just go right to that, you could go right to that. So the formula is just like accounting for the fact that you need to know what term 0 is. I guess, if that makes sense. Or not. Anyways, I just erased that. You can, and it's an open book test, so you will have that, I hope, in your notes. So like, it's pretty easy to like get the general term of an arithmetic sequence, but like, you also don't even need that. If you had a sequence that was like 1, 4, 7, 10, you can tell it's going up by 3. I know that the term 0 would actually be -2. So I could like right away just say 3n minus 2 is going to be my formula. Like if you didn't want to do the whole thing. Okay, have I said too much about that? Yes. Moving on. Okay, that's arithmetic. Geometric?
No.
Geometric is just, instead of adding or subtracting, it's multiplying. So geometric's when it's going up by a common ratio. So increasing by a common ratio. By a common ratio, which we're calling R. Yeah.
What about, is there like one for dividing as well?
It's going to be the same.
Oh, the same thing?
Yeah.
Alright.
Yeah, it's still geometric.
Alright.
So to get the common ratio, we're just doing same thing we did to get D. We're taking term 2 and we're dividing it by term 1. So in this case, like 10 divided by 5 would be 2. And you can see he's getting multiplied by 2 every time. Or like J-Ball said, if it was getting divided by 2, what would our common ratio be? Yeah.
Okay, 1/2. Yeah.
So if it was going like 40, 20, 10, 5, it was like going the opposite way. Your common ratio would just be, 20 divided by 4, which is just a half. So your common ratio can be multiplying or dividing, but it's always written as a multiplication statement. Okay, and the formula for geometric is Tn equals a times r to the power of n minus 1. You're not writing any of this?
At least he's truthful.
Yeah. Maybe you learned all you need to know from the Kahoot.
Oh, I learned so much. That again.
I think that I can do listen.
I think we should too. It gets some of those terms out of the way.
It's a good way to start it off. It's exciting.
Yeah, it's very exciting.
Is the thing still recording?
Oh yeah, it's still recording. This is gonna be a good. Aren't you glad you
Yo.
missed today?
Oh, Mr. Thomas coming back on the runners. Yeah. Yo.
You couldn't. Yeah, you're missing this, guys.
That'd be awesome.
Okay. Should we make our formula? T subscript n equals, what's A?
A would be.
Let's use this one.
Would A be just be 5?
Yeah, 5. What's R? 2. To the n minus 1. Look, this one's even better. You don't even have to simplify it. It's already done. But whatever you do, don't multiply the 5 by the 2. Okay, let's practice using it. My note is so messy. Let's say we wanted to find the 5th term. So 5 times 2 to the power of 5 minus 1. Solve that. What's up? I highlighted it. A plus n minus 1 in brackets times d.
That's what I thought.
Okay. I'm going to highlight this too. Okay, what'd you guys get?
Bless you.
Guys, I hope all you people at home are calculating this.
I'm calculating right now.
I mean, the at home listeners. Is it?
Yeah, 16.
3 times. That's 16 times.
That makes sense too, because like if we're doubling it every time, 40, 80, yes, that checks out. All right, amazing. Wait, what if we knew that, can we, experiment time. This is gonna be good. What if we know like, what if they give us a TN? Is it still gonna be good to solve this? I feel like we're gonna have to solve for an exponent. I don't think this is gonna be good. Let's just try it.
No.
Well, I guess I have to pick a real value. Let's pick 320. Okay, let's say you know that the nth term is 320. What term is it? Can we solve for that? Do we have the skills?
Let's see.
I don't know. Tn equals AR to the power of n minus 1. So we know 320 is equal to 5 times 2 to the n minus 1. What should we do to solve this? Fatima?
Do we have to like guess like the exponent?
We might have to, yeah.
Yeah.
Well, what could we do first before we start guessing?
We just like
We could simplify something.
320.
Like with what?
Divide by 2 or something.
Not 2.
4,
5.
5. Okay, yeah, 5.
Well, because there's a 5 there. We could divide both sides by 5.
Oh yeah, and then the 5 from that side would be gone. It would just be 2 exponent. You know, like.
I don't know. What's 320 divided by 5?
64.
How'd you get that so fast?
Mario 64.
It's just 300 is 60, and then you add 4.
That's
Just with the
genius.
20.
Guys, did you hear Elijah? Okay, good call. 64 equals 2 to the n minus 1. And then, like Fatima said, we could just guess. That's fun. Or if you're really good at your 2 exponents, you could also write 64 as, okay, I feel like I know 2 to the 5 is 32. So 2 to the 6 must be equal to 64, right? True? I think so. Because 2 to the power of 5 is 32, and then we just times it by 2 again, and we're there. So check this out. I could write, have you seen this before? I could turn 64 into 2 to the power of 6. And then, guess what? If they have the same bases, their exponents must be equal to each other. So now I know that 6 must be equal to n minus 1. Is that too extreme?
Wait, can you repeat that again, please?
Yeah. I turned 64 into 2 to the power of 6.
Oh, yeah, that's
Just because, whatever, I just knew it was that. And then if they have the same base, like I know the left side's equal to the right side, so they have to have the same exponents then. Because they have to. Yeah.
so we could just like ignore like the base.
Yeah, because I know the exponents are equal. So now I know n has to be 7. So that's cool.
Yeah.
Kind of, I don't know. All right, and that's all you have to know about sequences. And then there's only one more thing to learn, and it's series. And series are just sums of sequences. They're like when you add all the sequences together. Cool. I'm gonna stop recording.